Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have the count the number of good subarrays. So on this question, what they have given to us, given an integer array nums and an integer key, return the number of good subarrays of nums. And now what is a good subarray? A subarray of ARR is good if there are at least k pairs. If there are at least k pairs, there can be more than k pairs also, but there should be at least k pairs of indices such that ij follow this I smaller than j and array of I and array of j both are equal. So they should be equal and this condition should be followed. A subarray is a contiguous non-empty sequence of elements within an array. I think this is very intuitive, you guys should have heard of. So on this test cases, if k equals to 10, the only good subarray is the array nums itself. So only this nums is altogether a good subarray. So there is no implications behind this, but on this test cases you can get the gist of this particular question. So if k equals to 2, then you can get four different good subarrays. For the first one is 3 1 4 3 2 2, where there has two pairs. Which are two pairs? 3 is a group. And how many pairs of 3 3 is one pair, and 2 2 is a group. How many pairs of this? One pair. So we have total 2 pairs and k equals to 2. And if I consider 3 1 4 3 2 2 4, like I guess the entire array, how many good pairs we have? Considering this 3 3 1 pair, 4 4 1 pair, 2 2 1 pair, right? So how many pairs we have? 3 pairs. So that means here we have more than k pairs. If I consider this, how many good pairs? 4 4 2 2 2 pairs. 4 3 2 2 4, how many good pairs? 4 4 2 2, right? There are 2 good pairs. I think the question is very straightforward. Like for a given subarray, if you choose two indexes I and j, and if their values are same, you can consider it as a good pair, and if there are at least k good pairs, then you can consider this entire subarray is good. This entire subarray is a good, and now we have to return how many good subarray we have at to our given array. And here you can see the constant is very high, like 10 raised to the power 5. So one brute that is very top of your head, that is of we will generate all of our subarray, like pointing to L at a particular index, and we will move our R. So for every, like you can iterate from I, you can run 2 for loop I and j. Your I should be iterated from 0 to n, and your j should iterate from I plus 1 to n. That is very brute, and like this way you can generate all of your subarray, and you can consider how many of them are good. So that is a standard big of n square solutions you can write on your own, but I'm not going to like go deeper on the brute, because brute is very easy to write it, and very intuitive also. There is no brain challenges altogether, and brute is altogether not. So basically just on the interview, just on upfront of the interview, just state there is a brute of big of n square. I start from 0 to n and j start from I plus 1 to n. Mostly if that is a top product based company, and the interviewer should be looking for the optimal solution, he or she mostly not going to ask you to implement the brute. He or she just happy with the high level. You can give the overview of the loopings you will do. So that should be sufficient. So now we will jump on the most optimal solution. So on most optimal solutions, can you guys tell me few things? So can I close it? Yes, I can. So I am looking for few things. So what actually looking for? So if there is a subarray kind of things, then if you are following our sliding window playlist, then you might be aware of thinking of a sliding window kind of things. So what actually is coming top to our brain? So if you write the brute, so let me just quickly write the brute. If you by chance miss the sliding window playlist of our, so I will suggest definitely go to the sliding window playlist. There I, on the very initial video, I get the problem intuitions building, actually how you can identify a problem of a sliding window. So if there are 2 pointers, if I can write the things, the brute on the very high levels, then you can get the gist. So you have 2 loops. You should have 2 loops. 1 minute, guys. So it's some problem of my pain altogether. Yeah. So if we have these things, right? So if we have 2 loops, one starting from I start from 0 to n, and your j start from and your j starts from I plus 1 to n, I plus 1 to n. So and you are considering a window, of index I to j. You're considering a window of index I to j, right? Index I to j. So if that is the case, then so by name it is stating we are considering a window. Subarray means what? Subarray means a window of I to j, a window of I to j. If that is the case, then we should have to think of a sliding window, because the brute is basically pointing to think of a sliding window kind of thing. So we have a window of I to j, and there is a, the way we are moving our j pointer, we are basically doing the expanding of our window. Now just to top of this, our brute, can we build our optimal? So what actually we are looking for? So okay, so what actually contributing to my answer? So first build the mathematical things out so that we can think on the intuitions very clearly. So I know how many pairs we can select. So if you can go to the question, this is nothing but how many pairs of same elements you can form of subarray I to j, subarray L to R, let's suppose L and R the subarray you are considering. How many pairs of same elements you can build considering this formula? This formula is very brute, like very standard. There is nothing on this super magic on this formula. So that is basically they are looking for how many pairs of I and j you can form such that I and j are both same. So if you are following our permutation combination, and if you did a very basic maths on class 11 and 12, then I guess it's very intuitive. So if you have n elements, what we are looking for? If you have n identical elements, let's suppose we have n identical elements, right? If we have n identical elements, and we are looking, we are basically trying to get two out of them. So out of n identical elements, how many ways we can choose the two? How many ways we can choose the two elements? That is nothing but nc2. And now if we can write it nc2 in the formula, n factorial divided by 2 factorial into n minus 2 factorial, right? And if I can do a little bit derivations of this, n into n minus 1 into n minus 2 factorial divided by 2 factorial into n minus 2 factorial. Very basic maths. N minus 2 factorial is going to be cancelled. So n into n minus 1 by 2, right? 2 factorial is 2, because 2 into 1 into this, so this 2. So that is our formula, right? That is our formula for if we have a group from L to R for a particular element's contributions to a pair, what is the formula? How many counts of them? So n is nothing but count of that elements, as simple as that. So you will put n into n minus 1 by 2. That is very basic mathematics. Like if you are trying to solve this kind of questions, so this is a very 11 or 10 standard mathematics currently, right? So okay, we now get something. Okay, Shouvik, now if you can give me something like A, B, A, C, C. Now I know how many count till now we have is nothing but, let's suppose A occurs n times, let's suppose A1 times, B occurs let's suppose B1 times, and C occurs let's suppose C1 times. So it is nothing but A1 into A1 minus 1 by 2 factorial plus B1 into B1 minus 1 by 2 factorial plus C1 into C1 minus 1 by 2. The formulas that we just saw, the formula that we just derived. So we are putting the things in the formula. Into the formula. How many distinct elements we have? And for every distinct elements, we have to by the formula we can know what is the contributions to the count. So now if you are understand till this point, so the next things is very intuitive. So in sliding window, if you are following us on the last video, so I will definitely suggest guys, please first check out the sliding window playlist once. So I think on video number 1 or 2, I that is a 42 minutes video. Let me check it out also. So if you can go to our playlist, so on playlist sliding, if you can open the sliding window. So on this one, you please check this out, like longest nice subarray. This video is definitely needed, where I have giving you the my own template explanations I have provided here. So and and I will give a high level gist of my template, but I am not going to very deeply because there is already a detailed video I have done. So on sliding window, we start our L and R to 0 index, and we are basically by R pointer we are basically expanding our window. We are basically expanding our window, and there are some conditions by which we are moving our left pointer, So left pointer is nothing but, when we are moving our left pointer, is basically shrinking our window, So by our right pointer we are expanding our window, and on left pointer we are shrinking our window. So what is the gist? That is the very basic template which we already had a detailed explanations. Now on this particular question, what is the conditions? This condition is what? If we are able to define these conditions, then we done. So we know for every sliding window there is a concept of when we have to shrink. So on this particular question, when we have to shrink, when we move to our left pointer, when let's suppose we hit a count, we just define. So when our count is greater than equals to k, that means we already have at least k pairs which are satisfying, and we have more than. So let's shrink at a points where this conditions is altogether invalid. So when this loop is altogether execute, your left pointer is land on a point where from left to right, the window you are considering, it is just on point of invalidity. It is a just of point of invalidity, right? It is a just of point of invalidity. So now take a case. Now if I can write it, let's suppose I have a good test case. Let's suppose 3 1 2 3 4 5 6 and 1, and let's suppose I have k equals to 12. So your left is going to be initialized at here, and your right can continue move, and you know, your every right move, you need what is the current number. You need current number count, how many number of times this number has occurred. So for these reasons you definitely need a dictionary. So in dictionary, when your count is altogether moved till this point, your count of 3, how many it is? 6. So what is the contributions? 6 into 5 by 2, we are already seeing that is nothing but 15, and your k is 12. Before that, when k is, let's suppose just before of this point, when my r is at these positions, what is the contributions? 5 into 4 by 2, how much is 10? So it is still under 12, right? It is still under 12. So when first conditions of validity occur, so we will keep on moving our r, until the first points of validity occur, So that is nothing but L is 0 and R is at 5 index. On this you can see 0 1 2 3 4 5. When my R is at this index, so considering this L to R, my first points of validity occur, and if that is so, then we are shrinking our window. So when we are shrinking our window, our L move to this index, right? If our L move to this index, so again, how many till this to this, how many L we 3 we have, again 5, and for 5 it is 10. So after moving to this, our first points of invalidity encountered, and loop is in this inside loops is going to be terminated. Count greater than equals to k is going to be terminated. So L is at 1. So when it is going to be terminated, L as 1 and R is at 5. It is terminated, right? So now what is the contributions? So it is nothing but where your L pointer is altogether lie, because the reason is from your R, all the left are valid. Where my current left is standing, I know that is the point of first invalidity. So standing at my right, where my left is, I know that is the first point of invalidity. So till its left, all are valid. Considering this right, all of its left are valid. Where my left currently is, just of this, just of its left, all are valid. So index 0 is valid, index 1 is valid. Let's suppose. So for our case, L is standing at 1. So I know it is the first point of invalidity. So which of the index are valid? 0 is valid, only 0 is valid. Let's suppose your L is stand at index 3. So which of the indexes are valid then? 0 is valid, 1 is valid, 2 is valid. So these all are valid. As your now what is the count of this subarray? Considering R as the last, what is the count of subarrays? What is the count of good subarray? It's nothing but where your L is standing. Because if L is 3, we know 0, 1, 2, all are 3 valid, because it is very intuitive, right? Because index is 0 based. So where my invalidity index of L is standing, so that is nothing but already a +1 already done for it. So maybe you guys are thinking, maybe of L minus 1 should be my answer. L minus 1, because if you do L minus 1, you are going to add 2 here. But how many there? 0, 1, 2. Because index is 0 based. So directly you can add your answer plus equals to L. Where your L is standing, because index is 0 based. So where your L is standing, it is nothing but that many left you can still consider, because your L is just standing on the first point of invalidity till of its left, considering R as a fixed. R is fixed, na? Considering R as a fixed till of its left. So here you can see. So if I consider a bigger test case like this, and let's suppose your R is at this point and your L is at this point, and if I can number 0, 1, 2, 3, 4, 5, right? So that is the first point of invalidity. So then this is for sure valid, this is for sure valid. Maybe if there are more indexes, that should be also valid. So what is the answer? How many? So this one first valid, this one second valid. So where your L is standing, that is just the points of validity. All if your right is fixed, how many then valid? L is standing at invalid. All of the left are valid. It is as simple as that, guys. So that is altogether the intuitions. And now I will go to the code iterations. You will definitely get the gist. And if you are not getting at any points, please go to the video that I mentioned. On that video, I have basically given you my own template explanations. I use my own templates to this particular question. I will explain the template definitely, but I will not going to get on the very low level of the things which actually I have taking from my template. So I have initialize my left and right to be 0, 0, and I have initialize my default dict and in to be the length, and I have answer and count that we are discussing, and I am running up. So that is my own template. We will loop from R less than equals to n, and we have count greater than equals to get. So that means there is a point of validity. We have to make our L to land to a certain points where the first invalidity altogether start, right? And that index, the L is standing, I know all of its left are valid, and as index are 0 base, it is altogether, if I can directly add an answer plus equals to L, it is going to be sufficient for our answer. And finally we are doing to R plus 1. So that is my own template, and now I will explain what actually for this particular questions we have to play the games. If you understood the formula, I think you already have to be very good state to write the entire things, because the other things just the formulas I have written and the template I have followed. So I will definitely ask you to don't go through the next explanations, which I will do the code explanations. You will first go to that video that I have just seen, this video. Please go to this video, this longest line survey video, and post that you can go to the points of the explanations before this, which we are going to the code iterations. Before the code iterations you should be able to write your own code. So now I will giving you the code iteration. So by right pointer, we will obviously consume the number we are consuming, and we will increase the counter of my default tick. Very straightforward. And we will need, what is the last count of this particular number? It is nothing but we just increase our right. So the last count before consuming the current occurrence, how many, what is the last count we have? It is nothing but the current count minus 1, right? The current count is going to be increased. So what is the last times this particular number contributions? Direct formula. It is nothing but the last count into last count minus 1 divided by 2. What is the new count? New count is nothing but the last count plus 1, because we just consume a particular elements. We just increase its count. So new count should be last count plus 1. And what is the new count contributions? New count into new count minus 1 by 2. Same thing, same formula. And what is the count then? We can just subtract the last contribute, because for this particular number, what is the last contributions we are already calculating to our count? Just omit it out and add the new count. We are done the same things. We have omit the last contribute, and we have add the new contribute, right? So if you understood this, your right pointer movement, then your left pointer movement is which we are doing inside this internal while loop, it is just of the reverse of what you have done to the right pointer movement. So that is the exact template that we are following from the last video. So that's the reason I am requesting to you guys, please go to that video. Otherwise you might not get the feel of this particular question solution. I will definitely suggest you to go to the at least 1 times 2 times, please watch that video, so where I have explained in details my template. So here you can see that I now on this for loop I have to do the exact reverse. What I have done here, I have to do the exact reverse. So what is the last count here? I have just taken from nums of L. What is the last contribute? Last count into last count minus 1. What is the new count? Now new count, where my last times I am consuming more elements. I have just add the nums of R. So on and these for loops you guys should be aware of. This for loops is going to iterate for shrinking. Outer for loops is going to be iterate for expanding. So here we are doing the shrinking, right? So when we are doing the shrinking, so my new count should be the last count minus 1. So last time my new count is last count plus 1 because we are expanding. Now we are shrinking our window, so last count is going to be decreased by 1, and we have also decreased the dd of nums of L. Very intuitive, because the left pointer we are just neglecting. So we are also throwing 1 count down of my dd default dict also. And what is the new count contributions? New count into new count minus 1 by 2. And what is the same things? What is the count now? Count minus last contribute, count plus new contribute, exact same things we did. And we are moving our left pointer. To forward, because that is the very generic things. We are shrinking. We have to move our left. Same things. And finally we are adding to left, that we have already explained. So that's all about this particular question, guys. It is as simple as that. And if you have basically 2 things you needed, you definitely need this NC2 things. I think all of you should be aware of this, because it is 10 to 11 standard, and you have to know about this video. You should have gone through. Else, is there anything extra I have done on this particular question? Nothing. So that's the reasons I am repeatedly stating is, please follow the videos in the sequence that I am uploading. So because I am 90 to 95% sure, like on the very next like POTM, like particular questions that we are going to solve, like problem of the day that we are going to solve, that is just of the minor modifications, or the just 1 to 2 lines, or the formula additions of the last day questions only. Last days we are following the question already should be in our playlist. So that's the reasons we are building the playlist concept. So that's the reasons everything should be bunched on a single video. I will explain one topic as a very deep, and rest I will use that. Exactly what we did. So please go through the playlist on the sequence I am uploading. I'm requesting to you guys repeatedly. Otherwise, you will not get the entire feel of solving the particular question. Yeah. So now let's quickly discuss the time complexity. I guess it's very straightforward. I will directly write big of 2n. I am not actually want to again iterate to you guys, but I will do definitely. So 2n is basically our pointer is moving to for every elements 1 times, and my left pointer is also going to be. So this is not a n squared, because my left pointer, every time you can see my left pointer is moving by one ahead, right? One ahead, like this way. So my left pointer is going to be moved to every elements another 1 time. So that is going to be a very straightforward big O of 2n. And if you have a very minor doubt coming to your mind how it is big of 2n, please go to that video. We have discussed very details. If you are using this sliding window template, blindly you can write it big O of 2n, and just give this gist only. Our pointer visit everyone 1 times, left pointer visit everyone's 1 times. That's the reason it is big of 2n. Sufficient, more than sufficient. And do we use any extra space? Yes, we are using default tick, because we need the count to play the game here, right? So yes, it is going to be a take of big of n. So we can write it as a big of n. Yes. So that is the most optimal solutions, time and space complexity, guys. So if you guys are able to understand till this point, please do subscribe to our channel, and please share the videos who are also preparing and brush up their DSS skills. That would be helpful for them also. And please turn on the notification, so that when we are going to be live to our next video. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.